Welcome back, everyone. We're going to continue with chapter 3, section 3, and we're going to talk some new properties of functions, and we're going to start with even and odd. An even function means that f of negative x just is the same as f of x, so it kind of absorbs the negative. And let me show you a little picture of what I mean by that. If I have a graph here, and I have this point here, this is going to be x comma y, and this one here is going to be negative x and still just y. Versus an odd function, which means if the x turns negative, the y also turns negative. Just a little picture up here to show you what I mean by that. We have a graph that does something like this. I have a point here, x, y. This point here at negative x is negative x, negative y. So this is even, this one's odd. Now, most functions are not either. They're not even or odd. So let's do some examples. So part A here. Is it even or odd or neither? So what I'm going to do is I'm going to find f of negative x and see what we get. And when you raise a negative to the fourth power, it becomes positive. And when you raise a negative to the second power, it also becomes positive. So this literally becomes 3x to the fourth plus x squared minus 7, which is f of x. So this one is definitely even. And you can see it has even exponents. Part B, let's do the same thing. G of negative x is 2 times negative x to the third minus negative x. So this becomes, this still becomes a negative x cubed. So this becomes negative 2x cubed plus x. And I want to point out, I can factor out a negative 1. And this is negative f of x. So this is odd. Part C, so we'll do h of negative x. Negative x to the third plus 4 negative x to the second over negative x plus 1. This gives us negative x cubed plus 4x squared over negative x plus 1. Ooh, that is not f of x or negative x, so this is neither. Yeah. So it's not even or odd. So we don't get f of x back or negative f of x. We get something just different altogether. Just like I said, that's more common actually. All right, this one, we are missing a few graphs. So let's go here. All right, and we have, this is 4, it's at 4, 3. Here we are at 7. So this point here is 7, 1. And from here to here, that is 10 to 13. And we want to know where it's increasing, decreasing, and then constant, and local max and mins. or extrema, is the Latin way of saying that. So increasing, it's increasing from negative infinity to 4, right? Increasing as x gets bigger, y is getting bigger, and it stops at 4. Then it decreases until we hit to 7 to 10. And then it does not decrease after that. Decreasing. It's decreasing from 4 to 7, it looks like. And then it decreases after 13, it looks like. 13 to infinity. There we go. It is constant from 10 to 13. Local max, meaning where it peaks and valleys, or in this case peaks. Local max is going to be at the point 4, 3. And we would say that the maximum is 3, the y value. Local min is at 7, 1. And for this one, the graph is also missing. It does this. Let's do a different color. And let's label these points. 2, 4, 6. And what they want to know is when y, f of x, is positive. Well, it's positive from 2 to 4. Actually, these should be parentheses. We're not including the endpoints. And then it's positive from 6 to infinity, it looks like. Not too bad. All right, so we have a function f of x drawn here. And we have quite a few questions we're going to answer. What is the domain of f of x? Well, remember, domain are x values. That goes from -2, it looks like, to 7. What is the range of f of x? That's the y values. It looks like it bottoms out here at -3. Spikes at 6. What is f of 6? Meaning when x equals 6, what is y? Looks like we're at 4. What is x when f of x equals 6? Now we're looking at y value 6. So now we're up here. What's the x value? 5. X-intercepts? I'm gonna have to guess this is -1.5, it looks like. Looks like it crosses again at 1 and at 3. That's it. Y-intercept is at 3. So 0, 3. Over the interval, -2 to 0. This is these are x values. -2 to 0, it looks like we are increasing. And from 0 to 2, 0 to 2, we're definitely decreasing. From 2 to 5, 2 to 5, that's increasing. And from 5 to 7, we are decreasing. What is the minimum value? Now, these are referring to y values. The minimum value is way down here at -3. And the maximum value, it looks like, is at 6. up here. That's specifically when x equals 5. All right, average rate of change. This is right at the beginning of an introduction for calculus, actually. Average rate of change. When working with real-life problems involving linear equations, we found that the slope of a line can be interpreted as a ratio or a rate. And we kind of know that already, rise over run and so forth. If the x-axis and the y-axis have the same unit of measure, then the slope has no units and the slope is a ratio. If the x-axis and the y-axis have different units of measure, then the slope is a rate or rate of change. Meaning, the first one is just saying comparing up and down compared to left and right. The second one is saying that if we're comparing distance to time or velocity to time or something like that, then we're looking at a rate. All right, for a nonlinear graph whose slope changes at each point, the average rate of change between any 2 points, these 2 points, the xy, xy, is the slope of the line through the 2 points. So what this means, if I have x-axis, I have x sub 1 here, and y or x sub 2 here, and I have a graph. And this is now the point. This is x sub 1, f of x sub 1. And this is the point x sub 2, comma, f of x sub 2. And the line that goes through them is called a secant line. Secant line. Now mine looks horizontal, it doesn't need to. In fact, the one drawn on my notes are even nicer, you can see it. It can be at an angle. And the idea with the secant line is, although that can be useful, what we ideally want to do is get x sub 2 as close to x sub 1 as possible, so that we get, ideally, a tangent line. Now, I'm going outside the scope of this course, but this is really where calculus was born, was based on things like this. Now, we can see that we can use our slope formula to find the average rate of change of f from x sub 1 to y sub, x sub 2. And let's do an example here. So they want to know the average rate of change of this function as x goes from 1 to 4. So let's start here. So that just becomes -1 plus 6 plus 1. That looks like 6 to me. So the point 1 comma 6. Then we have x sub 2 is at 4. F of 4 is -4 cubed, 6 times 4 squared, plus 4. So this is -64 plus 16 times 6. Let's see what that is. 16 times 6, 96. Plus 4. Let's see what we get. Plus 4 minus 64. 36. 436. So these are our 2 points that we want to find the average rate, the secant. It's going to be 36 minus 6, y sub 2 minus y sub 1, x sub 2 minus x sub 1. It gives us 30 over 3, which is 10. All right, the symbol delta, you've seen this like a famous airlines. has this symbol, represents a change in a variable. This is the Greek capital letter D for like difference. So that's why they're using that. A lot of Greek letters in mathematics. Hence, the average rate of change of a function, which is the slope over the interval, can be written as delta y over delta x. This is a very common notation. You'll see that in biology, chemistry, physics, and stuff. A secant line is a line through any 2 points on the curve. So we're gonna do the same thing we just did before. We have a new function, we have new x values. So let's find our y values associated with this. So f of -1 is negative 1 cubed plus 3 -1 squared. And using our order of operations, -1 cubed is just -1 again. So it looks like a point -1, 4. Then we have x of 2 is 4, f4. So this is -64 plus 3 times 16, which is 48. So -64 plus 48, -16. So 0.4, -16. So our rate of change, we can even use there, delta y over delta x is going to be -16 minus 4 over 4 minus -1. Be careful anytime you have a negative in your formula. You got to be careful of that double negative thing going on. This gives me -20 over 5, which is -4. So that is the average rate of change, the secant line between those 2 points. Hopefully not too bad. Thanks.